This is a video series on Timesys TimeStorm IDE. Today we're going to be talking about how to use TimeStorm IDE to perform a full system trace. We're going to be using technology that's open source that's called LTT Next Generation. To start the tracing, we have to first set up our target for tracing. Timesys has prepared a document that outlines step by step the process of preparing your target system for Linux Trace Toolkit Next Generation. There are two steps. Step one is we have to adjust the Linux kernel. As you can see, in a Linux kernel menu config or xconfig, we have to select kernel function tester, kernel function graph tracer, and support for tracing block I/O actions. Older kernels may also have an LTTNG kernel tracer option. In the second step, we have to also add additional utilities to our root file system. If you are using Timesys Factory, you can simply bring up the factory configuration screen and add utilities such as control, user trace, modules, and tools to your root file system design. If, on the other hand, you are using a Yocto build system, you navigate to your local.conf file, and in there you can add an image install append option, and under that option you can list all the different utilities that we need, including loadable kernel modules or drivers for LTTNG. Or you have a second option of specifying tools profile option. It's a group of utilities and modules and the extra image features. Both approaches will result in LTTNG being added to your root file system. From the process perspective, running LTTNG consists of several steps. In step one, we create a tracing session and we specify the name for the session. In step 3, we are going to enable events, and that includes Linux kernel events of different type that we intend to trace on. Linux kernel has different events enabled when we configured LTTNG support. Then we continue to start the trace process, and after we collected enough samples that collect information on applications that we intend to trace, we can stop the trace and visualize the tracing results using some sort of tools. The trace itself, when we stop the trace, gets stored on the target system where the trace was running under your home directory, trace session name. Let's take a closer look into how TimeStorm manages tracing. On the toolbar, we have an LTTNG button where we have an option to set up a configuration for tracing. So let's click on that. TimeStorm uses the configuration, which I can create another one, specify a name. In my case, I'm going to run a tracing session on an IMAX 7. So let's fix the name, and let's say IMX 7 tracing. And we're going to select the hardware using TimeStorm's target management functionality. Okay, in the next step, we specify a session, and we're going to create a new one. You can specify here any name and click OK. That's going to create a session for the tracing, and you can see that it showed up above. Events panel allows me to inspect which events I want to trace on. If I expand all, you can see that there are many different events that I can trace on. I'm going to select it all. So I want to capture tracing of, or the trace of my entire system on all available events. Let's proceed with launching the tracing. You can see that TimeStorm is going to now start the LTTNG profiling, and I have several buttons. Tracing is in progress, so samples are being collected on the target. Now I can go to the target, IMX7 here, and I can run any types of commands that I want to capture in my trace. I had here a CP4 application, which I'm going to execute. It should show up in my trace. We're going to be looking for it specifically. It's done, and hopefully all the samples for that applications are captured in a trace. So let's stop it. At this point, I have an option to destroy the trace, or I have an option to import the trace into TimeStorm. So let's import it. TimeStorm is going to show a window where I can select which trace I want to import into TimeStorm's visualizer. So let's click Browse. You can see that there is a directory here that contains all the traces. So I've selected it, and let's click Finish. That's going to import the traces, and under S3, which is the session name, as I called it in the setup, I see tracers. Let's double click on the kernel. As you can see, TimeStorm is reading in all the samples that we've collected on the target. There are several windows in TimeStorm to visualize the trace, and again, since it's Eclipse based, I can double click on any of the views to expand into a full view. Here you can see all the different processes that have executed on a target, along with the process ID. So that's how I can identify which process is which on the target. You can see LTTNGs, you can see system level processes. All that information is captured. Why? Because they do get CPU time. And whether it's preemption or another reason for swapping out task from the CPU, it's captured in a trace. So let's look for our application at this point. There are several SSHDs connections, and I had a secure shell open to my target. So I'm going to assume that my CP4, here it is under one of the shells. So here are the two processes, process ID, and now I can scroll through this timeline and search for how the CP4 executed and what has preempted the execution of my application on the CPU. So let's scroll to the right. Here is the green colored bar for the CP4 process. And in the next step, I can zoom into it to see what was happening in here. There is this zoom in and zoom out, so that allows me to take a closer look at the timeline. And let's zoom in a little bit more on one of those events. You can see that there is a interrupted process here. So something has interrupted my process. Yep, let's look for another occurrence. And we're going to try to zoom in some more on one of those preemptions. Oh, this one looks interesting. We have several different colors in here. So we can see here that SSHD preempted my process, and there's a wait for CPU area here. So most likely my process was requesting some sort of access to hardware and got preempted. But also SSHD, the daemon itself, needed some CPU cycles, and I can see here the preemption happening. Again, I can zoom in some more, but to get a better understanding of what was happening. But I'm switching right now to resources, where you can see which IRQs have been also captured in my trace. So which interrupts both hard and soft IRQs. And here's my CPU time, collective CPU time two cores, CPU 0 and CPU 1. And then I have some statistics on different events that have been captured. So these represent all the different events that I've selected in the LTTNG trace setup. Okay. Let's return to the original view, and what other views are available here? Well, there is a certain period of time here that I can select, and in that time I can view which events have been captured. You can see here there is a sketch.run event type, and on the right hand side you have a thread ID and process ID as well mentioned. So I can confirm that specific events have been captured on the specific thread ID. And there's also the priority for each of those events that were occurring. So this is a default priority in Linux 20. And you can see here 8215. Let's see if that corresponds to CP4. 82, let's expand this, 15. Here it is, CP4. So these are indeed different events that have been captured on the CP4 process. Down below I have timelines, and I have ability to zoom in on those timelines. At the bottom timeline, by selecting a specific time period, I'm zooming in, and then that allows me to very quickly scan through the timeline, find the place where an application can be executing, and zoom in on it very quickly. So that's it. Tracing is a very capable feature, and as you can see in TimeStorm, it's very easy to set it up and to run a trace of the entire system that captures not only system level information, but also information about how your application competes for a shared resource such as CPU. Thanks for watching. Please see our other TimeStorm videos.